All right, so welcome back. So I want to consider the equations here. X 0, x equals x0 plus at, and y equals y0 plus bt. And here we're actually going to allow t to take on all real numbers, where these numbers, these constants here, x0, y0, ab, they're just some numbers. And so if those are just fixed numbers, what type of graph do these equations end up describing? So that's our question here. So we want to take what we looked at previously, and we want to kind of generalize it a little bit. So what we can do is, once again, try and solve one of the equations for t and substitute that into the other equation. So let's see what we'd get if we do that. So let's take that top equation, x equals x0 plus at, and solve that for t. So we'd have to bring the x0 over by subtracting it, and we'd have to divide by a. So that would be equal to t, and then we can substitute that in to our other equation. So y equals y0 plus bt. So plus b times all this stuff. X minus x0, all that divided by a. And then we just want to do a little bit of, and then that would be, actually that's it, yeah, that's replacing t. And then we want to just do a little bit of readjusting of this equation here. So if I bring that y0 over, y minus y0, and then bring the a out of the denominator and put it out of the fraction inside there and put it with the b, so I have b over a. Then I'll notice that this equation is actually in point-slope form, right, where I'm passing through the point x0, y0, and I have a slope of b over a. So it turns out this thing is actually just going to be a line with slope b over a that passes through the point x0, comma y0. So we're just passing through the point x0, y0. And so this is actually going to be a straight line. So in fact, we can actually take the equation of any line now, and using this idea of knowing a single point that it passes through and knowing its slope, we could actually construct their parametric equations. So here I have this as an example. Let me just mark the point here, x0, comma, y0, so he kind of stands out. And so I can make adjustments to my a, b, x0 or y0. Right, change the point that I'm passing through on the x. Maybe make it 3. Maybe make the y, I don't know, let's make it maybe -2. Right? And by adjusting the a and b, we can change the slope. So this slope was b over a. So if we make b bigger, right, the slope's going to get steeper. If we make a bigger, right, the line's going to get flatter. And of course, if we make a or b negative, if we make a negative, then we're going to have a negative slope. But if we turn around and also make b negative, then we'll be back to a positive slope once again. And so we get kind of a little interesting equation here. Now, we kind of maybe would have suspected that we'd have some kind of linear equation since the two pieces were linear. But remember, just because of what you have there isn't always going to dictate what you'll get. For example, what we considered this equation, x0 plus a t squared, comma, y0 plus b t squared. And again, I'm going to let myself range from minus 200 to 200, just so I can see what kind of graph I'm getting here. And you might notice here the green graph stops right here at this point, right? In fact, let me just change that back to 0 for a moment, and you'll see that it's stops there. But if I come over here and change that to 0 and make this 200, it actually crosses the same part of the graph twice as t ranges, and you can actually see this if I make it go, say, to I guess we're on to point C and add a slider for C, then you can see as we go positive where C is at, negative values. Once I reach the positive numbers, what's actually going to happen is I'm actually going to be doing the graph backwards, and I can show that to you here. If I make t be 0 and then show you the slider here, starting at positive, you can see the line's actually going backwards, redrawing itself. So it's a straight line too, but it's actually a straight line that stops. So that's just kind of a little variation, and we can adjust this and change things, maybe make that minus bt squared, and I have no idea what it's going to look like now. Let me go from minus 200 to 200, and it looks like, once again, we're getting a straight line, but it's going in a different direction now, the negative slope. Okay, so you can, of course, adjust things by changing some facts of your equation and getting a different graph. But this one here just ended up being a straight line. So it's kind of a neat little result there.